Hi, my name is Lisa Sercombe. I am the Detection and Liquid Handling Product Specialist at Millennium Science. This video is on TRF, Time Resolved Fluorescence. Part 1 of this video series is on Assay Technology Basics. So what is TRF? Time resolved fluorescence can sometimes be confused for kinetic assays, however they are two separate entities. Kinetic fluorescence is usually reading a normal fluorophore such as rhodamine, Texas red, FITSI kinetically, reading the same well over and over again over time. TRF utilises lanthanides within the periodic table, on which there are only 4 that you can use to run TRF chemistry. And these lanthanides exist in a cage, and the purpose of this cage structure is to protect the ion and use it as a transporting mechanism throughout the assay. The lanthanide is then attached to your target via a binding arm, so you need to know some basic information about what it is you're attaching the lanthanide to, whether that's a protein, peptide, oligo, and if you're aiming for the N-terminus, C-terminus, etc. This study here illustrates the benefits of TRF chemistry. In this study, 4 labeling strategies are used to investigate the interactions between chemokine receptors and ligands, 3 of which are traditional fluorophores, and the 4th is a lanthanide known as europium. And clearly you can see a significant leftward shift in sensitivity between using a fluorophore and lanthanide in detecting a target. So what is it about lanthanides that allow such sensitive assays? There are several reasons for this. First is Stokes shift, the delta between the absorption maxima and emission maxima. If you look at a traditional fluorophore such as fluorescein, it has a 488 excitation and a 588 emission, and a narrow Stokes spectral shift overlap between the 2 spectra. If you have a narrow Stokes shift, like with fluorescein, and don't set your bandwidth appropriately, you will get something called internal quenching, resulting in reduced count, sensitivity, and signal to noise, as well as reduced Z primes in your assay. And as a result, it is somewhat compromised. Lanthanides, on the other hand, have a near UV spectra with around a 330 to 340 excitation and a red shift emission around 615. There is a huge difference in Stokes shift with 0 overlap. The second reason has to do with the decay profile of fluorescent intensity. Think about an antibody where we excite a fluorophore. We get a very short acute signal that comes and goes quickly. Unfortunately, the background we often pick up exists at the same time that we get the signal, and it can be difficult to differentiate true signal from your fluorophore. Whereas a lanthanide has a decay profile that is extremely long, which means that you can time gate it and can wait until all of the background noise has gone away, and then you gate a window where you're reading your specific signal. So through the combination of optical filters and dichromatic filters with a wide bandwidth, in addition to using time gating, you can garner extreme low limits of detection, i.e. sensitivity. Now with time-resolved fluorescence, there are generally 2 main categories of TRF assays: homogeneous and heterogeneous. Heterogeneous TRF assays are similar to ELISAs. It involves adding components and wash steps, and it may also have a separation and filtration step. Homogeneous, on the other hand, as the name suggests, is a mix and measure assay. No washing steps are required. Thank you for watching this video on TRF. Part 1, Assay Technology and Basics. Make sure to watch part 2 and 3 of this video series, where we go into more detail on the specifics of homogeneous and heterogeneous TRF assays. For more information on this or any of your detection and liquid handling needs, please feel free to email me. And finally, if you are interested in any of the products that Millennium Science, Jomar Life Research or Biotech, a part of Agilent, provide, please refer to the websites listed here.